Okay, hi guys. It's day 8 of our fabulous vacation at home.
Very funny.
I know, we're going a little stir crazy in the house. I wish the weather was nicer. Hope you're all holding up okay. I have some more experiments for you today and another build challenge. Where we left off was the egg challenge. And so I can tell you, they've been in here all weekend. They don't smell the greatest. It just smells like vinegar,
It smells
sulfur.
like pickles.
Pickles.
It smells like Sharpies.
Pickled.
That's what it smells
Pickle
like.
Sharpies.
You're so weird.
Pickle Sharpies. Pickled
Anyway,
Sharpies.
I hope you guys still have your eggs and your parents haven't thrown them away in disgust. So if you're just catching up with us now, the challenge was to put an egg, just a raw egg after you wash it, into a cup of vinegar and just cover the top of them and see what happens. And so I had two hypotheses. One hypothesis, my first one, was that I had a white egg from the store, which I referred to as a
Store-bought egg?
like a store-bought egg, like a factory chicken, right? An egg from a factory chicken. And then an egg from a local farm nearby that friends of ours gave us. And I hypothesized that the white egg shell, the factory chicken, would dissolve faster than the brown because I assumed that this chicken was more fed a more nutritious diet. It's a free-range chicken, very happy chicken. And they just give it feed, but then it roams around their farm and eats grubs and bugs and lots of protein. But in doing that, it also picks up the calcium it needs to form the shell on the eggs. And so it would have a thicker shell, thus taking longer to dissolve than perhaps a factory chicken. The other hypothesis that I thought would maybe be that perhaps this one, oh, here's my phone. This one would have a harder shell because it has like a scientific diet. It's a diet that scientists have formulated for them to get the optimal eggs, but that might not be the best.
Father.
I know, I'm going to pause it.
It's your boy.
Okay, we're back. So as I was saying, the other hypothesis was that if this is fed a scientific diet meant for, to produce good produce, then perhaps this will have a bigger shell than this one. But it turns out that less than 8 hours later, this one was dissolved. Not completely, but I stuck my hand in it and squished it, whereas this one was still hard.
You could not squish it.
And I could not squish it. So it still had the hard shell on it. So this one did dissolve faster. The white one did dissolve faster than the brown one. But I'm not sure on the diet. I can only say that I think it's because this one has a better diet.
Now we gotta go find where the people made the egg.
And now we're going to play with them. So I want you guys to run them under cold water.
With the stuff in it?
Yep, and then dump it out. And then you can touch it and bring it over. Go ahead.
How do I dump it out?
I will.
Will you please go rinse it off?
Not touching that.
Then you don't get to touch it when it's squishy bouncy.
Yes, that's perfectly okay with me.
Also, we're going to do the next activity with these, and then I'm going to give you the design challenge. We'll be working off of Pushes and Pulls B.
Do I dry it?
Which is take them out and rinse them off, and then bring them over. Take them out, rinse them off, and bring them over. That's not rinsed off. Gross. All right, you gotta go wash that off. Put it in the sink, Lucy, and rinse it off.
Whoa!
So you want to put it in the sink and rinse it off, and you can completely wash it. Yeah, and then I'll tell you what you can do with those things a little bit. So we are on Pushes and Pulls B. And I'm going to pause this and wipe the table off because it's got gross goo on it. Oh, is it going?
Yeah.
All right, so That's the white egg that Emily has.
Whoa, I thought that was supposed to be a brown egg.
This still has some stuff on it. The brown egg does.
Yeah.
Like it's still got a lot of
The winner.
shell on it.
So it's still hard?
No.
It's
not hard.
Nasty.
Mhm.
Whoa.
That looks pink.
Yeah, it does. So bounce it on the table a little bit. Don't let it fall on the floor. So if you're brave, you can take these outside and do an egg toss. And since they're not so brittle, they're more flexible. You can
Let's do that.
toss them back and forth, right?
Oh!
Like that. You don't want to do that.
I don't want to do that.
All right, we got some cleanup to do. And we're back.
Again.
So that's an example of what not to do. You guys didn't see the wreckage, but you know,
We should have.
page 1 and 2 of our stuff, it ended up having egg all over it, as well as my computer and
So we're
some
not
of
doing
my
that
face. And yeah, but we still have 1 egg left.
My egg.
Provided that Addie doesn't break it, or Lou doesn't break it, or Emily does, or I don't break it.
I'm
whatever.
probably not going to touch
Anyway,
it.
if you're gonna toss the egg and not catch it, you should go outside.
Yeah.
Because that made a mess, but it was easily cleanable.
It also stinks really bad.
Yeah. So
It
now
smells like pickles.
we smell like pickles.
Oh.
So the next thing we're gonna do with this egg is we are going to put it in some liquid. And the science behind this is that this is a cell. So it's basically a chicken sex cell. It hasn't been fertilized. And so a cell has a cell membrane around it that's called semi-permeable. And what happens is it will
Technically, there wasn't a rooster.
It will allow liquid to pass through the semi-permeable cell membrane. And if we put it in one sort of liquid, it will make the egg bigger, right? And if we put it in a different type of liquid, it will shrink the egg. So I think first we'll just straight up put it in regular water, and we'll see what happens, right? Okay, so rinse out one of those cups and wash it. Just fill it with water, regular cold water.
I want to play with it.
You can play with it for a little bit.
Yeah.
Okay, so we're back. Careful, these are scientific instruments. So we put our egg in the water, and we're just gonna watch and see what happens.
It looks bigger on the camera than it does in the real life.
Yeah, it looks magnified in the water.
Yeah.
But do you think it's gotten bigger?
I don't know.
No,
Mm.
it hasn't.
I don't know. All
I
right.
mean, there's little creases.
We're gonna,
It's hard to
we'll
tell.
just keep an eye on it over the day, and
What if I poke it with a pencil?
we'll see what happens. All right, so what do you think's gonna happen if you poke it with a pencil?
Let's do that at the end. How about a pen?
Maybe tomorrow. All right, so I wrote out page 2, pushes and pulls B. And so it's fine.
Man.
What we're supposed to do is follow the directions on part B. So if you want to pull up page 2, and then it wants to know what happens when spring scale A and spring scale B both push with 4 newtons of force. So we'll demonstrate this for you so that you can see using our spring scales. All right, since you don't have these at home. So go ahead, do it.
Okay. Wait, we need to go on the Newton side. What do we have to do?
You have to go on the Newton side.
I'm on the Newton side.
Okay.
And then we push till we get to 4.
Yep, so you both get to 4.
What?
Careful.
Bro, I'm at 4. No, I'm not at 4 anymore. I don't think that can be at 4 at the same time. I did it before, so get to 4. And then push further. And then you push back. No, don't pull, push. Push a little
She
further.
is.
Push.
She's pushing. There.
Bro, because that don't get me at 4. Almost. We were both at 4 for like 2 seconds.
Is that hard to do?
Yes.
I want to try with Mama. I want to try with
Okay.
Mama.
I was able to do it when I was just doing it myself.
Let's make sure these are calibrated, right?
Emily,
So-
you want to spill water on the table?
Yes.
Stop.
Okay, so we'll do this. And then we'll do... Going to give you a teacher look.
I'm going to give you a student look.
I get enough of that at home. Oh, wait.
Oh, wait.
Okay. So we're going to hold it here, and you want the green ledge to get to 4. Okay, hold still, hold still.
Hold still.
Okay.
Cinda. I said hold still. Almost to 4.
Okay.
Rapunzel.
Are you? I'm at 4 too. I thought that was
Whoa.
easy, guys.
No, it's not. You also probably fixed it.
All right, so what happens when spring scale A and spring scale B both push with 4 newtons of force?
It's hard.
It is hard to get them to 4, but when you have them at 4, what's happening?
Well, it's being hard. I don't. Nothing really.
Oh, I know.
Well,
They
push at each other.
These things shrink.
They push at each other. Right, these go in, and they go up to 4.
They go in.
So what do you think, Lucy?
That they're at the exact same and
They're the exact same.
and they're pushing at the same level.
They're pushing at the same level.
How do you know that? Well,
How
yeah.
does she know that? That's good.
Yeah, well, that's because that's what the reader said. Ah!
Yeah, what the measurement said. Okay, so here's something else to try. So part B says hold one of them still. Okay. All right, so we're gonna start.
I'm gonna do the hardest job.
Okay,
I'm gonna hold still.
on the table. So set it on the table.
Wait, we're supposed to predict first.
Yeah. Okay, so you're gonna set it on the table. So it says if you hold spring scale A still and push with a 4 Newton force with spring scale B. So that'll be our hold. Stop.
I'm being spring.
That'll be our hold. And this, you got to be able to see this though.
I can't. I can't sit. No.
All right. Yep. You have to be able to see this. Okay. So you got to hold it.
Emily, I swear to goodness. I can see it.
You have to hold it on the table. All right, and then B, that's going to hold still. Can I show you how I want you to do it?
Yes.
All right. I want you to hold it still.
I was doing that.
You were doing this.
I was not doing that. Watch. It's going to be
Hold it still. But your hand is over this, and that's going to cause a problem. So anyway, and then this one is going to be the only one pushing. Okay, so that's going to hold still, and this one will push. So what do you think the newtons will be on spring scale A? This one.
5. No, I'm guessing like a 3 or maybe a 2.5. 5. I don't think it will
7.
be
One says more and one says less.
7.
So not equal.
No, Lucy, not
So I'm going to
7.
say 3 or 5. That's our guess.
Oh, okay.
All right, ready?
No. So I'm going to push it.
Watch your hand back here. You know, push it to 4. Hold it steady. What's that one at?
4.
It's at 4. So we're going to do A. Measured force on
It's
A.
in the middle.
So were you correct?
No. Kind of. Because we said 3 or 5. And
Okay, you had less and you had more.
No.
Oh, you had less and you had more. Okay, so, but it measured an equal force. So explain what's going on.
Both of us guessed 1 off.
Why do you think it was equal?
Because this is the same amount of whatever's in this one. So if you're gonna push it, it's gonna be the same. Yeah.
All right, so they're exerting the same force.
I don't know how to explain this.
I know. All right, and so science has given us a way to explain that. This is Newton's third law. So Newton's third law is for every action, there's an equal and opposite reaction. So the challenge for today is to build a machine that demonstrates Newton's third law. So it can't be a push from you. It's got to be a push from something else. If you go out and you YouTube or you Google machine that demonstrates Newton's third law, there's all sorts of possibilities. I plan to do something with a balloon.
Ooh. Dang it, now I hate.
So I will put up another document. I can't wait to see what you guys come up with. Have fun and play. And we'll talk to you tomorrow.
And don't drop your eggs.
And don't drop your eggs on you. Go outside and
then drop your
see how far apart you can get.
But make sure you have 2 eggs just in case you break one.
And do your own laundry right away. And don't make more of a mess for your
And don't tell your parents.
And don't tell your parents. You can tell it. Mrs. Red said no. Don't make a mess. All right. Till tomorrow. Good luck.
Bye.